Something in space is older than our sun. It is a tiny speck of dust, smaller than the width of a human hair. It carries a secret that rewrites the story of our cosmic origins. This ancient messenger traveled across unimaginable distances. It survived for billions of years. It was protected inside the frozen heart of a comet. This is not science fiction or a lab theory. It is a physical object scientists have held and studied on Earth. That fact feels like a small miracle, a whisper from before our solar system existed. The universe keeps its oldest memories in the most unlikely places, waiting for us. To understand this story, you first need to understand what a comet is. Think of it as a cosmic dirty snowball, a relic from the birth of our solar system. Comets are made of a mixture of ice dust, frozen gases, all clumped together with bits of rock. They spend almost all their lives in the coldest, darkest regions of space, far beyond the orbit of the farthest planets, in a vast reservoir called the Oort cloud. For billions of years, they drift in this deep freeze, perfectly preserved. But sometimes, a gravitational nudge sends one on a long journey inward toward the sun. As it gets closer, the sun's warmth begins to vaporize its ice, creating a glowing cloud, or coma, and a spectacular tail of dust and gas that can stretch for millions of miles. For centuries, we saw comets as omens or celestial wonders, but we never knew their true nature. We assumed they were made of the same materials as the rest of our solar system, born from the same initial cloud of gas and dust around our young sun. But in 1999, NASA launched a mission to challenge that assumption. This mission was a brave hunter, designed to chase down a comet and snatch a piece of it. Its name was Stardust, and its target was a comet named Wild 2. The goal was audacious and refreshingly direct. Fly through the comet's dusty tail, catch some of the particles, and bring them back to Earth for study. It was the first mission of its kind. The journey of Stardust was long and complex. To catch the comet dust, the spacecraft was equipped with a remarkable tool: a tennis racket-sized collector grid, filled with a substance called aerogel. Aerogel is an incredible material. It is a silicon-based solid that is about 99.8% air, making it one of the lightest solids known to man. It looks like a ghostly frozen smoke. Its unique structure allowed it to capture the tiny, fast-moving comet particles gently, slowing them down without vaporizing them on impact. The particles would embed themselves in the aerogel, leaving carrot-shaped tracks that scientists could later follow to find the samples. In January 2004, Stardust had its encounter with Wild 2. It flew through the coma, braving a blizzard of particles traveling at over 6 times the speed of a rifle bullet. The spacecraft's collector grid was extended, capturing the precious dust. After the encounter, the grid was retracted into a sealed capsule, protecting its cargo for the long trip home. 2 years later, in January 2006, the capsule re-entered Earth's atmosphere, blazing like a meteor, before deploying its parachutes and landing gently in the Utah desert. The hunter had returned, and inside its capsule was a treasure trove of cosmic dust, the first pieces of a comet ever brought back to our planet. The real work was just about to begin. If you're into this kind of deep space detective story, tap subscribe and like to keep this voyage going. When scientists at NASA's Johnson Space Center in Houston received the Stardust capsule, they treated it with the reverence of archaeologists opening a long-lost tomb. The process was painstakingly slow and careful. The canister was opened in a specialized clean room, an environment purer than a hospital operating theater, to prevent any contamination from Earth's own dust. Inside, the aerogel collector was waiting, holding its secrets. Using powerful microscopes and delicate instruments, researchers began the monumental task of finding and extracting the captured particles. The grains were minuscule, many of them smaller than a grain of salt, embedded within the ghostly blue aerogel. It was like searching for microscopic needles in a haystack made of smoke. As they examined the samples, the science team found thousands of tiny captured grains. Most of them were just what they expected. They were minerals. They were compounds that clearly formed within our own solar system. Olivine, pyroxene, common minerals found in asteroids and on Earth, which form at relatively high temperatures. This finding was itself a surprise. suggesting that materials from the hot inner solar system were somehow flung out to the cold regions where comets form. But among these familiar particles, the scientists began to notice a few that were distinctly different. They were strange outliers, like a few foreign words mixed into a familiar language. These odd grains looked different. They were not what you would expect to find in an object born from our solar system's primordial disk. The proportions of their elements were all wrong. This was the moment of discovery. The first clue that stardust had brought back something truly extraordinary. These few special grains were not native to our cosmic neighborhood. They were visitors from another time and place, ancient travelers that had been caught up in the formation of Comet Wild 2 billion years ago. The treasure chest from the void contained more than just local artifacts. It held relics from the wider galaxy. The excitement in the scientific community was palpable. Finding these grains was like finding a Roman coin inside an unopened Egyptian pyramid. It just should not have been there, and its presence demanded a new explanation. The team had to be absolutely certain. They subjected these tiny particles to a barrage of sophisticated tests using tools that could analyze the composition of a sample atom by atom. The evidence mounted with each test. These grains were not from around here. They were far, far older than the Earth, older than Mars, older than Jupiter, and yes, even older than the Sun itself. The hunt had paid off beyond anyone's wildest dreams. Quick break. If this blew your mind, hit like, subscribe, and share. Drop a comment. Which part surprised you most? So what were these ancient particles, and how could scientists be so sure of their age? These tiny specks are called pre-solar grains. The name says it all. They are mineral grains that formed before our sun, Sol, was born. They are literal pieces of other, older stars. These grains condensed from the hot, expanding gases thrown off by stars in the final stages of their lives. Some were born in the gentle winds of red giant stars, while others were forged in the unimaginable violence of a supernova, a catastrophic stellar explosion. For millions or even billions of years, these tiny specks of stardust drifted through the interstellar medium, the thin gas and dust that fills the space between stars. The key to identifying them lies in their atomic fingerprint. Each grain contains a unique mix of isotopes. Isotopes are different versions of the same chemical element that have a slightly different weight, because they have a different number of neutrons in their nucleus. The Sun and our solar system have a very specific and consistent ratio of isotopes for elements like carbon, oxygen, silicon. It's like a family's DNA. The stardust samples held another major surprise, one that added a new layer of drama to the story of our solar system's birth. They found minerals that could only have formed at extremely high temperatures. They found crystals of a mineral called forsterite, which solidifies from a molten state at temperatures well over 2,500 degrees Fahrenheit, about 1,400 degrees Celsius. This was a complete puzzle. Comet Wild 2 formed in the Kuiper Belt, a region of space beyond Neptune where temperatures hover near absolute zero. How did materials forged in fire end up in an object made in a deep freeze? It was like finding a freshly baked lava rock inside an Antarctic glacier. The presence of these high-temperature minerals in a frozen comet strongly suggested that the early solar system was a much more violent and turbulent place than previously thought. The old model envisioned a neat, orderly process, with hot materials staying close to the young sun and cold, icy materials staying in the outer regions. But the stardust results shattered that picture. For these heat-forged crystals to end up in Comet Wild 2, there must have been a massive transportation mechanism at play. Material from the hot inner regions of the solar system, near where Earth and Mars would form, must have been launched outward to the distant frigid zones where comets were born. One leading theory proposes that powerful jets and outflows from the young energetic sun acted like a cosmic cannon, blasting material from the inner disk out to its farthest edges. If you find this story of cosmic mixing and ancient stardust as fascinating as I do, please, take a moment to share it with someone who loves science. The stardust discovery elevates the status of comets from simple, dirty snowballs to something much more profound. They are guardians of ancient history, cosmic arcs that preserve the oldest solid materials. They formed so far from the sun and spent most of their existence in the deep freeze. Oort cloud, Kuiper belt. Very little change since their birth 4.6 billion years ago. Unlike planets, which were geologically processed by heat, pressure, weathering, comets are pristine relics, leftovers from the construction of the solar system. This makes them invaluable to science. Studying a comet is like sampling the original recipe for our solar system, but pre-solar grains add a deeper layer. Comets guard galactic history. Think of one pre-solar grain's journey. Born in the fiery envelope of a dying star, ejected into interstellar space by a supernova. Drifted for millions of years, a lonely traveler in the dark. Joined a collapsing cloud of gas and dust. Survived turbulence, survived heat, flung to the outer edges. Captured by a growing clump of ice and rock. A comet. Slept frozen for 4.5 billion years. Then a small robotic hunter came and brought it home. So, why does the discovery of a microscopic grain of dust, older than the sun, matter to you? It matters because it deepens our connection to the universe in the most direct and physical way possible. It confirms that the famous phrase, "we are stardust," is not just a poetic metaphor. It is a literal scientific fact. The atoms that make up your body were forged in the cores of stars. The atoms of the planet you live on were forged in the cores of stars. The atoms of the sun that warms you were forged in the cores of stars. The Stardust mission went one step further and brought home the physical evidence, the ancient grains that traveled from those stars to us. This knowledge collapses the immense scale of the cosmos into something personal. This discovery invites a profound sense of wonder. It shows that our origins are stitched together from a patchwork of materials from across space and time. Our solar system is a blend of the old and the new, a cosmic melting pot. This idea can make you feel both incredibly small and incredibly significant. If this journey moved you, please subscribe, like, share, and tell us in the comments which moment sparked your wonder. More cosmic stories await.